Good morning, children. Today we'll discuss about radicals, basic radicals, acidic radical, and how to write the chemical formula of a compound. This is the lesson number 5, language of chemistry. In this chapter, you will learn about symbols of elements, valency, radicals, molecular formula, chemical equations, balancing chemical equations, and all. In class 7, we have discussed about chemical reaction, reactants, products, and all. And the word equation also we have discussed. In class 7, we have also discussed about symbols, the element. We know that the simplest pure substance made up of only one kind of atom is called an element, and a symbol is a short and unique representation of an element. And there are certain rules how to write that symbol. In class 7 we have already discussed this one. All the symbols are derived basically from the English or Latin name of the element. There are several rules. For example, certain elements, the symbol of certain elements are derived from the first letter of their English name. For example, phosphorus, the first letter is P, so the symbol is P. Oxygen, first letter O, symbol O. In some cases, the first two letters are considered to be as the symbol of this particular letter. For example, barium, Ba, the first two letters. Sometimes first and third letter are also considered as the symbol of that particular element. For example, chlorine, first and third letter Cl, chlorine. Sometimes the Latin name are used to derive the symbol of a particular element. For example, copper, cuprum. This is the Latin name. That's why the symbol is U. Gold, Latin name aurum, symbol Au. Iron, ferrum, Fe. Lead, plumbum, Pb. In this way, mercury, Hg, potassium, K, argentum, that is the silver, Ag, sodium, Na, tin, Sn, tungsten, W. Okay. Valency. Valency of an element is defined as the combining capacity of an element to the element. Now, element and element combine together to form a chemical compound. And this combining capacity of a fixed element of an atom is known as its valency. For example, in a molecule of water, we know the formula of water is H2O. In a molecules of water, H2O, one atom of oxygen is combined with two atoms of hydrogen. So the valency of oxygen is 2, because one oxygen atom is combined with two hydrogen atoms. Look at this formula. In a molecule of ammonia, look at the formula of ammonia, NH3. So that means one nitrogen atom combined with three hydrogen atoms. That means valency of nitrogen is 3. In a molecule of methane, CH4, one carbon atom is combined with 4 hydrogen atoms. So that means the valency of carbon is 4. Now valency of some elements, that means the noble gases, helium, argon, krypton, neon, xenon, radon, their combining capacity is 0 because they are inert gases. But nowadays there is a discovery regarding the compounds of xenon. Though xenon is an inert gas, but still xenon forms several compounds, and xenon have variable valencies. In this table 5.2, there are valencies of first 20 elements in the periodic table along with their symbol. These valencies are very important for writing the chemical formula of a compound. You have to remember all these valencies. For example, silicon, the valency is 4, phosphorus 3, sulfur 2, argon 0. This is the definitions of valency, or one-line definitions of valency, SCI vocab. In the next page, we'll learn about variable valency. Variable valency. Some elements have more than one valency. They combine with atoms of other elements in more than one way, forming different compounds. These elements are said to have variable valency. Copper. Copper has two valencies, 1 and 2. So for lower valency, As is important. Copper, lower valency, cuprous. Copper, higher valency 2, cupric. Copper in lower valency symbol will be copper within bracket Roman 1, cupric, Cu within bracket Roman 2. The suffix as is used for the case of the compound with lower valency, and the suffix ik is used for the compound with higher valency. For example, iron has two valency. FeCl2. Here one atom of iron combined with two atoms of chlorine, so it will be ferrous chloride. In FeCl3, one iron atom combines with three chlorine atom. It is the valency is 3. In the first case valency is 2, so it will be ferrous chloride, and this will be ferric chloride. Ferrous as is used to indicate the lower valency, and ik is used to indicate higher valency. Sometimes the valency is written in the Roman numerals after the name of the element, like this way: iron 3 chloride. This type of writing of formula is known as stock notation of a compound. Iron 3 chloride means ferric chloride, means FeCl3. Another element with variable valencies like iron and copper, silver, argentus, argentic, lead, plumbus, plumbic. Look at this as to indicate of the lower valency, and ik to indicate the higher valency. Tin, stannous, as for lower valency, ik for higher valency. Mercury, mercurous, as for lower, ik for higher. Next is the radical. Radical is an atom or a group of atoms containing charge. either of positive charge or of negative charge. That means the radicals are of two types. One is basic radical, another is acidic radical. The radical having positive charge is known as basic radical or a cation. It is written first during writing the symbol or during writing the formula of a compound. A radical having positive charge is known as basic radical or a cation, and an radical with the negative charge called anion or acidic radical. There is another way of classifications of radical. One is simple radical. When when radical contains only one type of atom, then it will be referred as simple radical. For example, sodium plus, written as Na plus, magnesium plus 2, chloride Cl minus. When a radical is formed by a group of two or more different atoms, then it will be termed as a compound radical. For example, ammonium NH4 plus, sulfate SO4 minus, ammonium NH4 plus. Table 5.4 and table 5.5 depicts all the types of radicals. Valencies of some basic radical: hydrogen symbol H plus, valency 1, sodium, potassium, K plus, ammonium, magnesium, calcium, barium, zinc, Zn plus 2, nickel, aluminium, chromium. These are the basic radicals because they contain the positive charge. Valencies of some acidic radicals: chloride, bromide, iodide, acetate, bicarbonate, you can say hydrogen carbonate also, nitrate NO3 minus, valency 1, nitrite NO2 minus, valency 1, hydroxide OH minus, sulfide S minus 2, oxides O minus 2, valency 2, carbonate CO3 minus 2, valency 2, sulfate, sulfite, nitride, phosphate. Okay, so these are the valencies of some basic radical and some acidic radicals. You have to remember all the formula of these radicals as well as the valencies of the radicals. It's very important for writing the formula of a compound. Next, molecular formula of a compound is very important. We know that compounds are formed by the chemical combinations of two or more elements, and they have the fixed composition by mass, fixed physical and chemical properties. Compounds are pure substances. Molecular formula of a compound is just the symbolic representations of a molecule of the compound. Now the question is how to write the molecular formula of a compound. While writing the formula of a compound, it should be noted that it is always electrically neutral, and this is the main key lines for writing the molecular formula. That means they are electrically neutral, means the total positive charge must be equal to the total negative charge. Now to write a chemical formula, the molecular formula of a compound, you should know the constituent elements as well as the valencies of the constituent element. Now first take an example for the case of that water. Now we know water contain hydrogen and oxygen. What are the symbols of water? Hydrogen and oxygen. Why we should write hydrogen first? Because hydrogen is the basic radical. Hydrogen is the basic radical. How you know that hydrogen is a basic radical? In the previous page, hydrogen is the basic radical in table 5.4. Symbol H plus, valency 1. and oxygen is an acidic radical. You have to write the valencies of each element on the top corner as superscript. Should write. So hydrogen 1, oxygen 2, and you have to just interchange. The valency. So that means the valency of hydrogen must be with oxygen, that is 1. Valency of oxygen 2 must be with hydrogen. Look at this, 2 must be with hydrogen, 1 must be with oxygen. So thus the formula will be H2O. Okay, so this is the criss-cross method for writing the chemical formula of the element. So first step, should write the constituent elements side by side, and while writing you have to remember that basic radical should be written first and acidic radical should be written the next. Then you have to write the valency in the both side, and you have to interchange these valency. So you get that molecular formula H2O. Now if there is a common factor, then it should be reduced to the lowest possible ratio. For example, while writing carbon dioxide, first dioxide, valence of carbon 4, so it should be interchanged with oxygen, and valency of oxygen 2, it should be go to the carbon, so it looks like C2O4, but the common factor is 2, and so the lowest ratio will be CO2. The common factor should be cancelled. That means you must cancel it. Should be cancelled. Next, remember that metallic part of the compound is always written first by the non-metallic part. That means basic radical should be written first and acidic radical should be written at the next. In similar line, magnesium oxide, Mg magnesium, that valency of magnesium is 2 and valency of oxygen is 2. So after interchanging of these valencies between basic radicals and acidic radicals, it will become Mg2O2. Since the common factor is 2, so the lowest ratio will be 1:1, and thus the molecular formula will be MgO. Look at this, common factor must be cancelled out. In the last example for writing formula, we will consider the formula of aluminum sulfate. How to write the molecular formula of aluminum sulfate? So by the name you have understood that the constituent elements or radicals will be aluminum as Al, sulfate as SO4. As aluminum mentioned first, that means it is the basic radical. Aluminum is the basic radical and sulfate is an acidic radical. So it should be written side by side, starting from aluminum Al, since it is a basic radical. Then you have to write the valency on the top corner as superscript Al plus 3. This is the valency, and table 5.4 reveal the facts of the valencies of aluminum is plus 3, and the next table reveal the fact that the valency of sulfate is minus 2. That's minus 2 is written at the top corner as superscript, and plus 3 written as the superscript on aluminum at the top corner. Now you have to interchange these valencies. 3 must be with sulfate, 2 must be with aluminum by criss-cross method. 2 3 2 3. So the formula will become Al2SO4 whole 3. Okay, but don't write SO4 3. You have to mention this bracket. You have to write this bracket because there is a 3 sulfate molecule. Okay, now the total positive charge 2 into plus 3 plus 6, total negative charge 3 into minus 2 minus 6. As the compounds are electrically neutral, that's why this you have to crisscross their valencies. Thus the molecular formula of aluminum sulfate will be SO4 Al2SO4 whole 3. If there are more than one compound radicals, this is the compound radical. Al plus 3 is a simple radical because it contains only one atom. But sulfate is a compound radical because since it is contains 5 atoms, 4 for oxygen, 1 for sulfur. More than one compound radical, then the number should be enclosed within brackets. But do not enclose simple radicals within brackets.